Hi, my name is Alexander and welcome to this new video in the nanoLuka series unboxing and first impressions. Today we have a new device. It is a true RMS multimeter. It is made by the company called Finest. I've never used any of their devices, but it was the cheapest on the market I could find. So let's open it up and see what do we get. For us to see this device in action, I've prepared a set of components that we're going to characterize and test operation of the multimeter. Later in the video I'm going to talk a bit about the RMS value, the root mean square value, which is actually what makes this device more powerful than general multimeters. In order to test it, we're going to use this friend of ours, an old friend of ours, one of the first devices that we got for this nanoLuka lab, the function generator from Siglent. It's time now to assemble the multimeter, so I'm going to put the probes. Depending on the device, the physical unit you're going to measure, this assembly is to be done differently. So take care how you connect red and black. So there's just one black slot, so obviously we're going to put the ground probe there. And now the slot where we're going to put the red probe depends on what do we want to do. So these two are related to the current measurements, and they differ in the intensity of the current they can take. So up to 10 amps and range of milliamps or microamps. What we're going to do right now is to connect right here, because this is where voltage, resistance, frequency and capacitance are measured. So let's do that. Let's fire up the device. In order to do that, we need to position this switch in the appropriate point depending on the physical unit we want to measure. So let's start by checking up the most basic function of every multimeter. Each should have it, or has it probably, and that is related to beeping if there is a short circuit. So basically it should beep if we put these together. Okay, that beeps. Okay, let's go back to the resistance, and you can use this button, it's called range, to select the range. It's currently in mega ohms. That was quite fun with the resistors. So let's now see what happens if we try to measure some capacitance. Here you can see that the range is set to auto, and now currently it's talking about nanofarads. So I have two resistors here. One is electrolytic, one is not. So let's see what happens. So the last of the introductory tests I'm going to do is to see how we can measure DC voltage using these two batteries. So let's switch to voltage right here. Right now it's saying that the range is auto and it's showing that it's AC. So let's see how we can switch that off and make it measure DC. Range, yeah. Okay, range is about volts and millivolts, so let's leave it there and select, yeah, should. Now AC is gone, so I guess that means we're measuring DC. Okay, let's see what happens. This is a 9-volt battery. It should show number close to 9 volts. Yeah, 8 point something. Yeah, I've been using this battery, so it makes sense that it's lower than 9. Okay, putting that aside, let's see this battery, which should point something around 1.5, and yeah, 1.6. That's fine. To continue the testing of the basic function of the multimeter, I've set up here a small circuit using the 9-volt battery and two quite large resistors in the range of kilo ohms. Putting aside the color code, it's quite easy to determine once again their values. They're the same. So this is something of 330 kilo ohms. Here is the same. So we have 660 kilo ohms. Actually, it's not yet connected. There's an open here. So what we're looking at is that there is the 9 volt over 660 kilo ohms, which is supposed to give us the current in the range of milliamps. So let's get this device into, let's configure this device for current measurement. So since we are expecting the current in the milliamp range, let's set up right here. And now I'm going to switch to microamps and try now what happens. Okay, right here we have 12.2 microamps. Another function of this multimeter we're going to test today is the temperature measurement. So this is the temperature sensor. Fortunately enough, this device is set to measure in Celsius, in degrees Celsius. According to the manual, again, it says that it can measure both Fahrenheit and Celsius, but only the change can be done only in the factory. Without going into the mathematics of the root mean square, let's just see what it means in the context of currents and voltages. Assume that there is an alternating electric current going through a resistor. Now, the RMS value of that alternating current is equal to the value of the direct current that would basically produce the same average power dissipation in that same resistive load. In other words, RMS value of an alternating current is the value of the DC current that would heat up the resistor equally as it does the alternating current. When we speak about the mains electricity, we usually say that it's 220 volts. It is important to note that this is not the amplitude, rather 220 is actually the RMS value of the mains electricity. So in order to get the RMS of 220, we need to have amplitude of 310, which basically means that our sine wave in the mains really looks like this. Now that we've brushed up on our knowledge of the RMS purpose, of the root mean square value purpose, let's test this multimeter on an actual AC voltage. So what I'm going to do is set AC voltage as an output of this functional generator. It will be just a sine, and then we'll be measuring on the multimeter. So let's see what happens. So sine, yes, frequency 1 kilohertz. Let's give it 50 hertz. Amplitude peak to peak, let's make it amplitude, let's make it peak to peak 2 volts. That's 2 peak to peak, and offset we're going to keep at 0. Now I am going to turn on the multimeter as well. So it's pointing here that we have AC as the default expected, expected signal. So let's see what happens after we turn on the output. Okay, so we're getting 0.717, which is actually the square root of which is the 1 over square root of 2. Don't get confused by this number 2 here. This is 2, but peak to peak. So it means this sine goes 1 volt up and then 1 volt down to -1. So this is 2 peak to peak. If we were to increase the amplitude to, let's say, 6 volts, we're going to get 3 over square root of 2. 6 peak to peak, that's 3 above and 3 below. So this is 2.152 on of the RMS value. Frequency is again 50 Hertz. So let's give it a shot and put 1 kilohertz, say. Now we can see here again the frequency quite correctly. That's all we've prepared for you today. I hope you enjoyed this unboxing and first impressions video of a Finest 703 true RMS multimeter. First we did some basic tests of resistance, capacitance and DC values of current and voltage. Then we saw a very nice, very handy possibility to measure temperature using this device with the provided temperature sensor. Then we spoke a bit about the RMS value, the root mean square, and its importance for electrical engineering. Finally, we did some tests. Since this is a true RMS device, we did some tests using a functional generator to see how we can use this multimeter to characterize AC signals such as sine wave or square wave. Thanks for watching, and please stay tuned in order not to miss any of our content that is coming up in the next weeks and months. To do so, please follow us on Twitter and Instagram. Of course, subscribe. And special thank you to all our Patreon supporters. Thanks for watching and see you around.